Hello there. We are in week 12. Towards the end of the course, I had kept week 12 open and I had asked suggestions from the course registrants about what you would want to know about in testing. And a few of you replied back in the forum saying, please give us an overview of mobile applications testing. So this lecture is oriented towards that. I'll give you an overview of mobile apps testing. Like all other testing fields, this is heavily domain dependent, tool dependent, and given that we are in the last week of the course and the focus of the course has been on algorithms, I will restrict myself to giving you a reasonably thorough overview, but we will not go delve into the details. So this is a lecture on testing of mobile applications. So here is what we are going to do in this lecture. I'll introduce you to mobile applications testing. We will understand what are the key challenges that are being addressed when it comes to testing of mobile apps, and what are the various types of mobile apps testing. And mobile apps testing is based on entities called emulators and tools. So I'll end the course with giving you an introduction of some of the good emulators that are open source that I know about. Feel free to try them out if you have your mobile app to test. So we begin with an overview of mobile apps testing, the challenges in mobile apps testing. So what is mobile applications testing? So like any other piece of software, it's yet another software program. It's written in a particular programming language, meant to run on a particular operating system, takes user inputs, produces outputs. It's like any other piece of software, but it's a mobile application, which means it's a software that is meant to run on these handheld devices on a particular platform given by the mobile device, tuned to a particular operating system, which is obviously not as big as a large server or a desktop application. So mobile application testing is a process by which an application software, like an app that is developed for handheld mobile devices, is tested for all the features. It should do what it's supposed to do, which is basically functionality. And because it's mobile app, its usability factor must be very high because it's important for the success of the app. And it should be consistent. Consistent in the sense that it should be consistent across an Android platform versus a Windows platform versus a iOS platform also. Mobile application testing, like all other testing, can be automated, can be manual also. Mobile platforms, they are either pre-installed when you buy a particular mobile phone or a device, or they can be downloaded and installed from any of the mobile software distribution platforms. One of the biggest platforms that we are aware of is Google Play. A related area of testing is testing of wearable applications, which are these Fitbits, Google, Apple Watch, Google Glasses, all these wearable devices which also have elementary computing power. Please note that we are not looking at testing of wearable applications, but some of the things that we will see today is also relevant to testing of wearable applications. So we'll begin with what are the challenges when it comes to mobile applications testing. So as I told you, a mobile application is another piece of software written in a particular programming language. So it goes through all the stages of development. Unit testing, software integration testing. For unit testing, software integration testing, you can do all that we did in the past. You could model it as a graph, you could use logical predicates, you could use mutation, any of the things that we learned can be used. When it comes to now after integration testing, we're talking about system level testing, which is an app working on a phone after being downloaded and installed and being made available on a phone, which is system level testing for a mobile application. That's what we're going to focus on. So when it comes to the system level properties or system level testing of a mobile application, what are the key challenges that are there? The biggest problem is what is called device fragmentation problem in this area. So what does it mean? It basically means that there are so many mobile phones, right? So many different mobile phones, very, very expensive phones, very, very cheap phones, phones that are feature rich, phones that have a good camera, phones that are very cheap, and so on. Huge range of operating systems, platforms, and phones. So the problem is each operating system has its own limitations. And each application that I develop, right, if I have to develop a particular app, it could be a gaming app, it could be something, it has to work across platforms. There are of course apps that are specifically tuned for working only on an iOS or on an Android, but most of the common apps that we develop, we expect it to work across platforms, across operating systems, and it has to be tested across multiple devices running on the same platform. If I take Android, which is by and large the most common mobile platform, mobile OS, there might be hundreds different kinds of devices that use Android, each with its own limitation and capability. So a particular app needs to be tested across each of these devices. The other big problem is when you say you have to test a particular app across each of these devices, a difficult to implement strategy would be to go and buy that device. Every day there is a new phone coming in the market. How are you going to go on buying devices? And if you have a particular app, test it across each kind of device, even across manufacturers. There are so many different phone manufacturers. It's very difficult to actually buy the phone and test it. So that's why we resort to these things called emulators, which we will see a little later in this lecture. So each of these mobile devices, what are their problems? They have different screen sizes, different resolutions, they have different memory, different hardware capability, different battery capability. Everything is different in each of them. So the next big challenge for mobile application testing is the fairly large number of network operators. It is believed that there are about 400 mobile network operators across the world. It looks like a small number, but from the point of view of testing, it is a large number. Some of them use common standards that you might be aware of, like GSM, CDMA, and all that. But if you see, a good number of them are also on less common standards. So when somebody operates a mobile network, it could be an Airtel or it could be Jio or whatever it is, if that company is using a common standard, then you say I test the mobile network as per that standard. But a good number of the network operators use less common standards. So across these mobile networks that are operating, you have to be able to test your app. They use a different kind of network infrastructure, so there is a challenge about how information flows from one network to the other. All these things matter a lot. So the next set of challenges are, as I told you, actually executing. Suppose you have a test case that is developed and packaged as a test script and you're ready to test. So you need to be able to execute it on a particular device. In a desktop, it's fairly common. You have a Windows desktop or an Ubuntu desktop. You can go ahead and write test scripts, configure a tool like JUnit, for example, to write test scripts. But that's not the same when you're executing a test script on a mobile phone. Why is it not the same? Because each different kind of phone or a device differ in several things. They differ in their keystrokes, their input methods, their texture, their display. You can't write a single script that will ensure execution across all phones, even if the platform or the OS is common. It's very difficult. And the other thing that is very specific to mobile apps, like web apps also, is that they have to be tested for what is called downloadability from a particular store. If they are available, let's say from Google Play Store, then it has to be downloadable. It has to be downloadable across networks, across devices. So that is a challenge that is very specific to mobile phones. The other thing that people test is what is called compatibility, which we discussed here, right? In this part, you have to be able to ensure that a particular app, if you claim it is compatible across devices, platforms, and networks. So these are the challenges. So before we move on and look at how typically, what are the typical main system level features that mobile apps are tested for, let's look at what are the biggest differences between a mobile application testing and a desktop application testing. On a desktop, the application is tested by using a CPU. We all know that. But on a mobile phone, the application is tested on mobile handsets. Mobile device screen is usually much smaller than a desktop screen. So as I told you, test script execution across devices is a challenge. Similarly, mobile devices have lot less memory than a typical desktop. That's also a challenge. Apps have to be developed for working within that memory. So memory testing is a very important feature. We'll look at that also. Mobile uses, as I told you, different connections, 2G, 3G, 4G, Wi-Fi, whatever you want. Desktop, they use broadband or dial-up or maybe Wi-Fi. They don't use anything else. Automation tool for desktop application testing will not work on mobile application because this test script that is written for a desktop is not easy to replicate to work on different kinds of mobile devices. So what are the main types of mobile application testing? So when I go and talk to you about types of mobile application testing, please keep one thing in mind. A mobile app is a piece of software, as I told you a little while ago. So it has to be written in a programming language, unit tested, integration tested, and let's say you have it ready. Now I'm considering system level testing, which is I'm taking the app as a whole, packaged, ready to be put in a mobile device and tested for various aspects. So that's the stage I am in, and when I discuss about types of mobile application testing, that's what I'm talking to you about. So the usual thing we always do for every kind of software, which is functional testing, we also do for mobile application. What does functional testing do? It ensures that the application is working as per the specified requirements, right? It may provide its main functionality. Let's say you have an app that talks about the traffic, it does tell you accurate traffic correctly. Most of the tests conducted for this are driven by user interface and call flow. You can, as I told you, you can use any standard testing tool to be able to do functional testing. Another important system level testing for mobile apps is that of usability testing. What does the word usability tell you? It is one of the quality attributes. This is testing that is done to make sure that the mobile app is easy to use and it provides a satisfactory user experience to customers. Most of us react that way, right? We say, I don't like this app because its UI is not good. UI is user interface. We say, I don't like it. It's difficult to use. It's not pleasing. I don't like it. And there is also a problem of native language UI, right? The same app that works here, let's say a bank that operates across several different countries, let's say a mobile app for that bank which provides similar features has to be in English for a particular country, has to be in the national language for another country. Let's say it could be French or German, or it could even be in Hindi, right? So the same app has to be usable. Usability is, should be easy to use, it should be usable at all, and not only easy to use, a user who's using it should be satisfied with the UI. So this is very important because it's one of the key factors to an app's commercial success, and it should test for uniform user experience across devices. You can't claim and say that I have an app that will look very good only on iOS. Its UI doesn't look very good on Android. That kind of apps don't sell. And it also, usability testing also tests for functionality, because the functionality of a mobile app is typically through user interaction. It tests for placement and sizing of the various things across devices. The next kind of important system level mobile app testing is performance testing. Here it is, as always, performance testing is testing done to check the performance and behavior of the application under certain conditions. What are conditions specific to mobile phones? One common condition specific to mobile phones that we all would have encountered is low battery. At the drop of the hat, mobile phones run out of battery. The next common problem that we all face is bad network, poor network coverage, low memory available because there are several other applications running in parallel, right? So there are several others who are simultaneously accessing the server. So these are the places that can slow down the performance of a mobile app. So performance testing for mobile applications focuses on these specific issues. It is to be done both on the client side, which is a particular phone, and on the server side, which is the server where the application resides on and keeps and fetches the data. Like for example, a Facebook mobile app needs to talk to the Facebook server. WhatsApp mobile app needs to talk to the WhatsApp server. A bank mobile app needs to talk to the bank server. The client is the phone, the application on the phone. The server is the database or the main server that application is talking to fetch data from. Performance testing is dependent on both the client and the server and is tested on both sides. As I told you, compatibility. Compatibility is, will a mobile app work in different mobile devices, across browsers, for several different screen sizes, different mobile OSs, Will it have the correct resolution, as I told you? Will it have local language features, and so on? Several different aspects have to be considered. Moving on, what are the other specific system level testing corresponding to mobile apps? The other one I told you is, this is one of the problems that we all face: runs out of battery, very slow, slows down. So that is what is called memory related testing. We know that mobile devices have significant constraints on memory, because that's the best memory that is being provided at a particular cost is already being provided by the manufacturer. So mobile related testing is testing done to ensure that the particular app manages memory and doesn't slow down the overall system. What does it mean to manage memory? For a mobile app, when it's a managing memory, it should mean that the app deletes temporary files, uses screens and other hardware resources optimally. What do I mean by optimally? So if you've developed a mobile app, you would be aware of a feature called a wake lock. Basically, wake lock tells you what to keep active and what to suspend. So for example, let's say you have WhatsApp running, and WhatsApp doesn't have to keep the screen on, the screen brightness and lit on all the time for it to be able to notify when a new message is coming. It'll have a small thread running somewhere in the background inside your phone, which will look for messages in your inbox, and when the messages come, it'll pop it. Whereas, let's say you have another application which is playing a movie, right, on your phone, then for that you need to keep the screen on. So wake locks are things that you write as a part of your mobile app, which tell you what to keep on in terms of the hardware resources: screen is on or off, volume is on or off, display is on or off, brightness is so much, and so on. So managing wake locks is an important part of memory usage. If you keep a lot of things on that you don't need all the time, then the battery, phone and memory is going to drain, and that's not good for the app's performance. So memory related testing tests for all these optimal usage of resources. The next is installation testing. As I told you, when it comes to mobile apps, some of them come pre-installed on a particular device, whereas others have to be downloaded and installed on a particular device. So this kind of testing covers installation, updating of an app, which we do very frequently, periodically, both system level functionalities and a particular related app, and uninstalling also is typically covered in installation testing. So going on, interrupt testing is another kind of mobile application testing. What it does is that, an application, a mobile app, might face several interrupts while installing or while in use. Remember when I told you about web-based testing, I told you the interrupts that people do are back and refresh buttons and so on. Similarly, for mobile apps, what could be interrupts? There could be a sudden call. It could be an incoming call, or you might decide to make an outgoing call, or there could be a message, there could be an incoming notification. You might decide to remove the battery while you're running a particular app. You might decide to charge the phone while you're running a particular app. You might suddenly lose network. So many other different problems could be thought of as interrupts. So interrupt testing basically considers the fact about a mobile app working correctly even if interrupts come, and in the worst case it tests whether the mobile app correctly goes into suspend state and resumes afterwards. Security testing is very important for mobile apps, because a good number of us who have smartphones, not only use our phones to make calls and stay in touch with friends and family, but we also use it for several critical transactions. Like for example, we use it for bank transactions, to transfer amount, to log in securely into our bank account. And very soon in India, you can use your phone for making as a credit card. You can use it to make payments. It's already there in the US. So security is a very important part of certain kinds of app. So security testing checks for vulnerabilities related to hacking, access control, authentication, data security, session management, and so on. There are several security standards that these mobile apps that deal with these bank transactions and credit card payments and all have to meet. One of the common ones is called CC, expanded as common criteria. NIST in the US has several standards. This is actually quite a deep area. You could have half a course on security testing, and a good part of it could be on mobile app security testing. I'm not going into the details. I'm just giving you a very, very high level overview on, just by telling you that this is an important area that needs to be considered. In the part of this week's lecture, I'll also tell you a little more details about security and performance testing that might be helpful, but by no means we are going in any depth in these areas. Please remember that. So the last one that I would like to discuss about is what is called location testing, which is again very specific to mobile apps testing. You would have typically experienced that connectivity changes with network and location. Suddenly you'll have no signal. Suddenly the signal strength will be very good. So you have to be able to test the functionality of a mobile app for these kind of changes also. The problem with this kind of testing is it's very difficult while you're developing an app inside your organization. It's very difficult to recreate this kind of a scenario to test it, right? Typically this happens when you're traveling, right? When you lose signals drop, signals come back for various reasons. If you're going to sit in your organization, in your testing lab, imagine how difficult it will be to recreate sudden drop of signals, sudden picking up of signals. So it is one of the difficulties that people face while doing location testing, is they may not be able to accurately mimic the change in location of networks or signal within the laboratory or development center and test. So apart from the various system level features that we saw till now, as I told you, you have to do the normal unit testing, integration testing, everything, because it's just another piece of software, and that can be done using any of the criteria that we've learned earlier in the course. And what we looked at in the just past few minutes are system level testing features specific to mobile apps. So here is a summary slide that I picked up from another website called Software Testing Class. So I thought I'll show you this slide because it gives a nice overview of the current state of the art in mobile app. So we'll just focus on this part first. It says types of testing. So at the back end, at the middleware, or at the device user interface. Back end of a mobile device, middleware of the mobile device, or at the user interface. At the back end, when I'm developing an app, I do integration testing. I do integration testing at the middleware level also. At the middleware level, I also do authentication, security testing, and device management testing, which talks about, releasing, keeping the memory intact, releasing system hardware resources that you don't need, and so on. But a good number of system level testing happens at the device UI level, which is what we talked about: installation, compatibility, user interface, functional testing, profiling of a device, interruption. All these things happen at the system level phase, and as this legend shows, unfortunately a good number of these cannot be automated. So it heavily relies on a person having knowledge about the mobile development environment, about the domain of the application, about the mobile OS, and then actually writing test cases to be able to pull out errors. The rest of it, like these kind of stuff, are heavily automatable. There are tools. I will tell you about some of the tools that are available in open source. So moving on to tools for testing mobile apps, as I told you, very difficult to buy every kind of device available in the market, to go around carrying your device, waiting for network to become low, battery to drain out. We can't do these things in the real environment. So what we do is we create simulated environments where these scenarios are depicted for a mobile phone and a mobile phone functionality is tested. So typically we use what are called emulators to do these. System level features that we discussed for mobile apps are tested using what are called emulators. What is an emulator? An emulator can be thought of as a system that again contains a piece of software. What does it do? It runs the software from one environment in another environment without changing the software. Like for example, using an emulator, you could say you configure it for this particular device that runs Android operating system with this as the screen resolution and this as the display brightness, and this is how the parameters, the touch screen coordinates in my screen looks like. And then for the same app, let's say you want to test it for the iPhone. So you say you configure it for an iOS which is for this particular device, iPhone device, which has this screen resolution, this kind of a display, and so on. So emulator lets you do these configurations of a particular system, software and hardware, such that you can run your app as if you're actually running it on the real phone and test all the features of your app that you want to test. How do they work? They work by duplicating the features of a real system in a software plus system setup. So here are three kinds of mobile emulators that are commonly known. First one is what is called device emulator. This is typically provided by the device manufacturers themselves if you want to develop an app or test an app. The second is browser emulator, which emulates the browser settings available in a particular mobile phone. As I told you, it simulates mobile browser environments. The third is a OS emulator, which is again provided by the particular firm that owns that OS. Apple would provide it for iOS, Microsoft would provide it for Windows phones, Google would provide it for Android phones, and so on. So here are some free mobile emulators that I am aware of. The first one is called Mobile Phone Emulator. You can download it from this site. It is used to test the display of a particular website on a cell phone terminal. Right, so as I told you, suppose you have a bank thing, a bank, Citibank online, the mobile app that's available. The way it is displayed on an iPhone will be different from the way it is displayed on a Samsung phone. So this emulator can be used to configure the display for these different ones and see how the particular display of a website looks like. Another emulator is MobiReady. This is a free tool for testing performance of a website on a mobile app. You can pick it up from this site. Then there is another tool called Ranorex, which provides a GUI testing tool for mobile apps. This is not an open source tool. You can download it for free trial from this website. Another tool that I am aware of is Jammu Automator, which is again not an open source tool, but there are free trials available. This is a scriptless cloud-based mobile test automation tool. So just to summarize this lecture, what I intended to tell you in this lecture in response to some of your requests in the forum was to give an overview of mobile apps testing. I am by no means an expert in this area, so I've managed to give you an overview that includes important system level features that are tested for mobile apps. Please remember that it needs extensive tool support, specific domain knowledge and testing to be able to test for mobile apps. Thank you.